Hello everyone to day 2 of Advent of Code. For those who don't know what Advent of Code is, each day starting from December up until 12th of December you get one task to solve that has two parts, and for each part you gain 1 star, and we have to collect all 24 of them for us to be able to say we have successfully completed Advent of Code. So today we're starting off with a day 2 called gift shop. So the task goes as follows. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole. Gleefully exclaims the nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here, and from there you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. For example, and here they're showing us an example of how our puzzle input would look like. And here they say that this puzzle input is wrapped for better text readability, but in our input it will appear on a single long line. So the ranges are all separated by commas. So 11 to 22 is one range, 95 to 115 is another range, and 998 to 1012 is another range, and so on and so on. And each range gives us its first ID and last ID separated by a dash. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any IDs which is made only of some sequence of digits repeated twice. So 55, 5 is repeated twice, 64, 64 twice, and 123, 123. Those would all be considered invalid IDs. None of the numbers that have leading zeros, 0101 isn't an ID at all. 101 is a valid ID that you would ignore. So this is telling us that it needs to be equal. So it needs to be equal from the both sides. It needs to repeat twice. So this is our clue. This is our first clue on how to solve a puzzle, but we'll go into that a bit later. Your job is to find all of the invalid IDs that appear in the given ranges, and then here we have the examples. For example, 11 and 22, 11 and 22 respectively are invalid. 95 to 115 has only one invalid ID, which is 99. From 998 to 1012 is 1010, and so on and so on. And our goal is to add up all of those invalid IDs in the example and to get a correct answer. So what do we get when we add up all of our invalid IDs? So let's start writing our code. I will again be using a Python because it's the most comfortable programming language for me. And yeah, so one of the things we have immediately noticed in the task is saying that a number 101 isn't a valid pattern. And why is that? Well, if we want to, valid patterns are considered usually like 11, 11, or 1 to 2, 1 to 2, and so on and so on. This cannot be a valid pattern. Although it does replicate itself, it can be like this. Although it does replicate itself around this middle part, this cannot be considered valid because we need to have two equal halves. This immediately tells us that numbers or the ranges that have a odd amount of digits are immediately going to be considered a valid, that do have odd amount of digits are immediately going to be considered as valid IDs. And everything else we will need to parse as per the task. So let's start. I will first start by opening a file, and for that I will be using an example input from the text since I cannot show my real input, so let's do that. So I will call it ID ranges line, and just to be more descriptive for what we are doing, and we will read that one single long line, which is basically like this. Next up with this, we want to split those lines. We want to split that line by the comma, which we have seen also in the task, so we can get the ID ranges that we will be using to do our operations. We can do that by just splitting by the comma, and we do ID ranges line dot split by the comma here. This allows us to get a list of strings that are separated as the commas, and I can show that by using a REPL, which is a cool utility that allows us to see how all of that looks like. And now we get this. These are all of our ranges, and we'll be able to work with them from now on. Since we need to get this sum, I will create a variable called part1 sum that is gonna be equal to 0, since we need to start from somewhere. And then we will initiate a for loop where we will have a variable ID range that is gonna go through ID ranges, and this will store a range. Now we need to get those two values. We need to get a start ID and end ID, or in this case a start of the range and end of the range. I will start by defining two variables again, start and end, and I will do ID range and I will split it by the minus. If we would go print start and end, we would get we would get all of these values here. This is the start, this is the end, and so on for all the other ones we have defined too. Now, one thing we want to be able to work with is with integers, since we need to somehow define a range. So I will map both of these values, start and end, to be casted into an integer. And in Python we can do it with a simple trick where we map the initial split input by giving it a function that it will use, and then to apply an operation on the elements that it accepts, in this case an iterable. And then, since this returns a map object, we use a list to convert it back to a standard list that we can use. So we will now create a for loop that will utilize our range, and we can do that by doing for id in range. In Python, this is basically like saying people are usually familiar with C++. This is basically just like I equals 0, I less than something, I plus plus. And here we will do start and end. Now we want to include the end ID in a range, and what Python does here is basically it stops right before the end value. So adding +1 here includes the value that we want to utilize. And now we can maybe start, we can slowly start going, we can slowly start to go write our function that will do the necessary operations to check if it is valid or isn't. We'll pass in an ID. Now, since it will be easier to check specific, things if an ID will be acted as a string, we will be passing ID. We'll be creating a new variable, ID as string, where we will cast our ID into a string. For me, personally, it was easier like that. but this can be done in many other ways. But yeah, so let's move forward. In our function, we have first said that our first constraint was that all the numbers, the length of the ID needs to be even. So we can do that easily. We can check that easily by checking if the length of the ID is divisible by 2. Is divisible by 2. If it isn't divisible by 2, if the remainder is not equal to 0, then we can just return a 0 as the ID, because as we know, anything starting with a 0 is not a valid ID, so this is perfectly fine. Now, one thing how I went about this is we want to be able to check if two parts are equal, but there is also a case where the number can literally be basically like this. And so what does this tells us is anything that has a repeating sequence is always going to be considered a valid invalid ID, I mean. And we can easily check this, if this is going to be okay or not, by using a data structure called set. What set does? Set basically creates from an iterable, it creates a collection of unique elements, unsorted unique elements. So if we have a bunch of ones, for example, bunch of ones, this inside the set gets turned into a 1. And then all we have to do is just check if this ID set is of length 1, we return the ID, which means it is an invalid ID. So we can do that immediately. If length of ID set is equal to 1, we return our ID. And now all we need to do, all we have left, is to check if two parts of our string are equal. In Python, this is actually pretty simple, because there is a thing called string slicing, and we can basically get specific parts of a string at specific indexes by basically doing something like this. For example, let's say we have a string ABAB, and we can get, I don't know, from up to index 3, we get ABA. And then if we want to get anything from index 3 moving forward, we can just do this. This allows us, since we know that our length of an ID is even, we can get a middle value, or in this case a middle index, and that's what we'll be using to compare these two strings. And how that would look like will be the following. We can create a variable called middle index, which is going to be equal to the length of the ID divided by 2. Here I'm again using a floor division, since it's since we want to avoid floating point numbers in any case, and so we can get an integer. And now all we can do is check if ID starting up until middle index is equal to the ID that starts from middle index and goes all the way to the end. Then we return that ID, and we want to have a fallback value of the function, that if none of these pass, that we just return a 0. And what we will just do is we will create a part1 sum, which is gonna be equal to this, and we will just do part1 sum, and we will pass here in ID, part1, we'll pass in ID as a string. Since we are working with, since we are returning here a string at most times, we want to cast this into an integer, so we will just do this. This is perfectly fine, and nothing will break because of it, so we can do that freely. And we will define a part1, and we will do part1 sum. and this should give us a solution. I will run it here. We get 122.777.5554, which, if you would check on Advent of Code, would be a correct solution. And if I would run this with my example, I'm gonna run it here. I'm gonna run it here, Python -u day 2. We will have to wait a bit, but this indeed is the solution on the website for my input. Now, what you might have noticed is that this solution is very slow. It takes a while to run it, and this is because we are doing a brute force approach. Honestly, this is the approach that only came to my mind at the moment when I was doing this. I'm not familiar with any other approach as of yet. I'm gonna have to check that, but moving forwards from now on, consider that we'll be doing a so-called brute force approach. So let's start now with part 2, since we have solved a part 1. The clerk quickly discovers that there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Now, an ID is invalid if it is made only of some sequence of digits repeated at least twice. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 2 times, 1, 2, 3, 1, 2, 3, 1, 2, 3 is repeated 3 times, 1, 2, 1, 2, 1, 2, 5, and 1 is 7 times, are all invalid IDs. For the same example as before, now these are valid, this one is valid too, and so on and so on. And now we get a new value. What do you get if you add up all of the invalid IDs using these new rules? So let's start with our part 2. I predefined a new variable part2 sum that I will actually immediately print out here, so we don't have to worry about it later. And I'm gonna define a new function that is gonna be called f_part2 that is gonna accept the ID, will return a 0 as a fallback, and we can immediately prepare our part2 function here. So, how do we actually check if a string is consisting of repeating substrings? For that, let's start by defining a function, and I'm just gonna call it repeating substring, since I don't feel very creative, and it will accept our ID, of course. So now we need to set up go through a few cases of this function. When we are checking for a substring, the substring can be at most long as at most half of our string long. So if our string has 10 characters, our substring can be at most long 5, because 5 plus 5, if there's gonna be 2 substrings, it's gonna be 10. If it is 6, that would immediately mean that the other substring would have to be also 6, but that's not possible. So we only look up to the half of the substring, half of the string, my bad. We can start by doing it for I. I'm just gonna name it I for I in range, and we will start from 1, since our substring cannot be of length 0, and we will do length of ID. We will do a floor division to get an integer and get the half of our string, and at the end we will add a +1, because what Python does is, as we have said before, this is it doesn't include the result of this. So if we are going from range 1 to 3, we will only have like 1, 2. So we add this to make sure the half of the substring is included. Now what we can make a certain optimization here. What we will do is we will check if the length of our ID is divisible by the current I of this range. Why are we gonna do that? Because, for example, if we have a ID of length 10 and we are checking a substring of length 3, that we cannot create a string of we cannot have a complete complete string of those repeating substrings, because 3 can only at most be 9, then 12, while it just skips over 10. So we will quickly do that check. Modulus of I doesn't equal to 0, and we will just continue, not return but continue. Now what we will check is we will again use a string slicing, and we will get our current substring that is being checked, and it will be checked up until that range variable. And the only thing that is left to check is if we can create a string, if we can create our complete ID using that current substring. So after we got our current substring, we will multiply that substring. With a length of our ID divided by the current range. This will allow us to see how many times the current substring actually repeats. So we'll be able to see if it is actually valid, and we do that by ID current substring multiplied by length of ID divided by I. This basically will structure our new quote-unquote new ID, and after we have done that, we will compare it to our initial ID. If they're equal, we will return from that ID how many times the current substring is repeating. I hope that was clear enough. But now we can successfully start writing our own part 2 logic. And in this case, we don't need to, we cannot have a check like we did in a part 1 if it is divisible by 2 or not, because we can have patterns like 1, 2, 3, 1, 2, 3, 1, 2, 3, where this has 9 digits, so immediately won't work. So we will again create a set to immediately cover the IDs that all have the equal digits. So we do if the length of the ID set is equal to 1. And now what it has said in the task is that it needs to be at least 2. So we will check and the length of ID is equal to or bigger than number 2, we will return that ID. Why are we using ID here instead of the ID set? Because our ID can be maybe, I don't know, 1, 2, 3, 4, and creating a set of these numbers is always gonna be 1, but they're not of length 2. So once we have done that, we will create a new variable called count of repeats. I guess that makes sense, and then we will call repeating substring, and we will provide an ID there, and this will be our variable that will hold how much times it is repeating. All we have to do again is to check if the count of repeats, just like we did before, is gonna be larger or equal to than 2. If so, we return the ID, and that should be it. So we can check first the example input. Whoop, what is happening now? Why is that not working? Did I forget? Return 0. I think that's why. Yes, it was. And we get an example. In an example, we get a correct value like it is on Advent of Code. And now all that is left to do is for us to get the value of our input. And as we can see, again, it takes a bit of a time to run it through, but we do get our correct solution. And that's basically all there is to it. I hope my explanations were clear enough. And as always, if you have any feedback, please let me know. I would love to hear it. And until then, enjoy your time and peace.